A 75 milliliter solution of hydrogen chloride with an unknown concentration is titrated to the equivalence point with 27.3 milliliters of 0.157 molarity of calcium hydroxide. What was the concentration of hydrogen chloride in the original solution? Okay, so the first thing we're going to do is write out the balanced equation. In doing so, we get that 2HCl plus CaOH2 yields CaCl2 plus 2H2O. The next thing we're going to do is write out our knowns and draw a picture of what's happening in the problem. So we know that there is a solution of hydrogen chloride with a volume of 75 milliliters, which we can convert to liters right now, and we'll get 0.075 liters. It's easier to do this step in the beginning, that way you don't forget to do it at the end. So we also have a solution of calcium hydroxide with a volume of 27.3 milliliters, converted to liters is 0.0273 liters. The calcium hydroxide solution has a concentration of 0.157 molarity. We're trying to find the molarity of the hydrogen chloride solution. So we're going to use the equation volume times concentration equals moles. We know that if we divide the moles of HCl by the volume of HCl, we will get the concentration of HCl. We also know that if we multiply the volume of the CaOH2 solution by the molarity of the CaOH2 solution, we'll get the moles of the CaOH2. So, to solve the problem, we are going to use the given volume of the calcium hydroxide solution times the molarity of the calcium hydroxide solution to get the moles of calcium hydroxide solution. So we get that there are 0.004286 moles of calcium hydroxide. Next, we're going to use the solution stoichiometry. We take the moles of CaOH2 we just found and multiply that by 2 moles of HCl for every 1 mole of CaOH2. So we see in the equation that there are 2 moles HCl for every 1 mole CaOH2. So this will convert our moles of CaOH2 to moles of HCl. By doing this, we get that there are 0.00857 moles of HCl. We then take the moles of HCl and divide it by the volume of HCl, which is 0.075. By doing this, we get the concentration of HCl, which is 0.114. So common mistakes in titration problems include using the formula M1V1 equals M2V2. Do not use this formula. This formula only works when no reaction has occurred. And it can also give you moles of the wrong thing if you don't use solution stoichiometry. So you could get moles of the CaOH2 when you really need moles of HCl. The next thing that is a common mistake is not converting milliliters to liters. If you notice in the beginning, we converted that in the known given information. That way we wouldn't forget to do it in the end.